Welcome back. This is Mr. Greenstein's Geometry. We're in Chapter 6, Section 3, Medians and Altitudes of Triangles. So an altitude in a triangle is the height of a triangle. It's from a vertex to the opposite side perpendicular. And if it goes from the vertex to the opposite side and it can't make a perpendicular inside of the triangle, then you extend the other side until you can make an altitude of perpendicular. Inside of a triangle, here's one altitude. If I draw the altitudes to all three sides, I find that it meets at one place in the triangle. This is always true. And this location here is called an orthocenter. So it's the intersection of all the altitudes of a triangle. It doesn't have the special properties like the other ones do. It has its own special properties, but that's more for advanced geometry. The only thing that you need to know is the intersection of the three altitudes comes at a place called the orthocenter. So the orthocenter for an acute triangle is always going to be inside of the triangle. For a triangle that's a right triangle, the orthocenter will always be at the place where the right angle is, so it's on the triangle. And the orthocenter for an obtuse triangle is always going to be outside of the triangle. Let's actually find the orthocenter for xyz. So I have x, which is negative 5, 3, 4, 5, negative 1, negative 2, 4, that's y, and then z is 3, 1, or negative 1. So if I connect these up, I get something that looks like that. And to find the orthocenter, I just look for an altitude. Well, one altitude is really easy. This one just goes straight down like that. Another altitude is going to be from x going towards yz. And what I'll do is I will come up with the slope of yz. And that's going to be equal to negative 1. So then the slope of the perpendicular, which goes through the slope of the perpendicular, which is going to be what I need for the altitude, is just going to be 1. And if I calculate the line that goes through that, I will come up with an equation, y equals x plus 4. Y equals x plus 4, so that means that I'm going to have a point at 0, 4, and that's going to go through x, and the location where both of these meet is the orthocenter. So the orthocenter in this case is going to be negative 2, 2. Negative 2, 2. Let's look at the coincident points that we have learned so far. We have the circumcenter, which is all the perpendicular bisectors. That's where it meets. We have the incenter, which is where all the angle bisectors meet. We have the centroid, where the medians meet. And finally, the orthocenter, where all the altitudes meet. And you need to commit all of these to memory. We'll talk about the rest of these and more in the next class.